Hello everyone, welcome you all to today's revision series. And today's revision series is basically we will be studying limits of exponential and logarithmic functions. Okay, so we will be discussing the concept in a very brief manner, then we will take some questions. So as you can see the screen, so today's topic of discussion is division of limits and our focus is limits of exponential and logarithmic functions. Okay, so I am going to introduce exponential series and logarithmic series, and both the series are infinite series. So as you can see, whenever so exponential function, like fx equal to e to the power x, or you can say fx equal to a to the power x, a greater than 0 and not equal to 1. And also whenever we take logarithmic function, it is fx equal to log x, and of course x is greater than 0. Okay, so we know logarithmic and exponential functions like this. And here today we are going to discuss logarithmic and exponential functions, how in limits they can be used. Okay, and specifically we have only three standard forms involving exponential and logarithmic functions. So before I introduce the standard form, so let me introduce what is exponential series. We define it as e to the power x equal to 1 plus x by factorial 1, x square by factorial 2 plus x cube by factorial 3 and so on. Okay, as I said, it is infinite series, it goes up to infinity. Now if I write e to the power x minus 1, obviously it will be x by factorial 1 plus x square by factorial 2, x cube by factorial 3 and so on. Okay, now let me take e to the power x, just a moment. Yeah. So e to the power x minus 1 by x, that is 1 plus x by factorial 2, x square by factorial 3 and so on. Now let us take limit x approaches to 0, e to the power x minus 1 by x. Okay, and if we take limit of the right hand side, obviously it will be 1 plus 0 0 0 0 like this. So we are getting the standard form of, one of the standard forms, limit x approaches to 0, e to the power x minus 1 by x, this is equal to 1. So we can use it as a standard form of a standard formula of limits. So we need to observe here, like power of e, denominator, and whatever is power of e, that should approach to 0. And of course 1 here. That means if I write here limit x approaches to 0, e to the power 2x minus 1 and 2x. So it will be here 2x, 2x, and when x approaches to 0, 2x also approaches to 0. So this can also be 1. So we have to see 2x power, 2x denominator, limit 2x should approach to 0, and of course here we have to have 1. So this is the standard formula, we can use it directly. Now coming to logarithmic series, which is also another infinite series, log 1 plus x equal to x minus x square by 2 plus x cube by 3 minus x to the power 4 by 4 and so on. And this series is specifically valid when mod x less than 1. X lies between minus 1, 1. Though we have the instances log 2 is defined, right? whenever you get x equal to 1, you can have log 2 equal to 1 minus 1 by 2 plus 1 by 3 minus 1 by 4 like this. But anyway, we are not going to that detail. Now our focus is now to evaluate limits and how to get the standard form out of the series. Okay, so it means if I write here log 1 plus x divided by x, it will be 1 minus x by 2 plus x square by 3 minus x cube by 4 and so on. Okay, so limit x approaches to 0, log 1 plus x divided by x equal to limit of the right hand side, that is equal to 1. So this is another standard formula for limit we are getting. So here also log 1 plus x divided by x. So observe the format clearly. Okay. Now the third one is, this is our first one, this is second one, third one is limit x approaches to 0, a to the power x minus 1 by x. Okay, so let's evaluate the limit. I mean limit of this function. So to get that, let me tell you, yeah, so substitute, yeah, you can say let a to the power x minus 1 equal to y. Okay, this implies a to the power x equal to 1 plus y, right? Now, if we take logarithm with base a of both the sides, or if you have a to the power x equal to 1 by y, x equal to log 1 plus y base a, right? So this is one of the properties of logarithm. So this is also, I mean, this can be converted to natural logarithm. Like for example, log 1 plus y divided by log a. So it means if I write here log x base a, that is equal to log x base e divided by log a. So that is the, I mean you can say that to convert, you have to change base of the logarithm, right? Okay, so logarithm and the basics and properties, I have already uploaded a video. So in case you have to, I mean, know regarding the basics of logarithm, so maybe you can refer to that video. And also here you see when we are changing the variable x in terms of y. So here x approaches to 0. This implies 1 plus y approach to a to the power 0. I mean 1 plus y approaches to 1 or y approaches to 0. Now coming back to limit things, I mean from here you can write limit x approaches to 0 means limit y approaches to 0 when x 0, y approaches to 0. A to the power x minus 1, that is y divided by x equal to log 1 plus y divided by log a, right? Divided by log a, or you can write here limit y approaches to 0, it is y into log a divided by log 1 plus y. Okay, and as we know, limit x approaches to 0, log 1 plus x by x, this is equal to 1. Now, if you take reciprocal of this, as limit x approaches to 0, it will also be equal to 1. It means limit y approaches to 0, y upon log 1 plus y, that is equal to 1. So, we are left with log a. Okay, so it means the third standard form we are getting limit x approaches to 0, a to the power x minus 1 by x equal to log a. It means to summarize what we are getting, I mean a standard formula which you can apply directly to solve some questions. So you may start with limit x approaches to 0, a to the power x minus 1 by x equal to log a, where a greater than 0, a not equal to 1. Okay, limit x approaches to 0, e to the power x minus 1 by x equal to 1, and finally limit x approaches to 0, log 1 plus x divided by x equal to 1. And here of course we have mod x less than 1. Okay, so these are the three standard formulas you can add to already studied standard formulas, standard forms of the limits. Okay, now let me take some questions so that you can be familiar with solving the questions. Okay, to start with, I can take some questions from, maybe I can take some questions from textbook. So in the beginning, maybe we can take some simple questions. For example, if you have limit, first question, limit x approaches to 0, it is log 1 plus 8x divided by 7x. Okay, so as for the standard form, this is log 1 plus x by x. So you have to observe 1 plus x, 1 plus something, that should be in the denominator, right? And here that quantity should approach to 0. So x, x, x. So here it is 1 plus 8x. It means we need to convert it into standard form. X approaches to 0, log 1 plus 8x means we need 8x here, right? So multiply 8x and in the numerator and denominator, right? And here already we have 7x. So we are getting limit x approaches to 0 means limit 8x approaches to 0, because when x closer to 0, 8 into x will approach to 0. So log 1 plus 8x by 8x, this quantity becomes 1 as per the standard formula. So you are getting here 8 by 7 as the answer. Okay. Second question is, so quickly we can take 5-6 questions and okay. So now next one is, if I write here, yeah, limit x approaches to 0. Here it is okay, log 1 plus x square, and here I am writing tan square x. Okay, so log 1 plus x by x, it is the standard form, and x approaches to 0. So limit x approaches to 0, when x approaches to 0, x square also it approaches to 0. Log 1 plus x square, we need x square in the denominator. Okay, so it is x square by tan square x. So we are getting limit x approaches to 0, log 1 plus x square by x square. So limit of the product equal to product of limits. So limit x approaches to 0. Here it is x by tan x whole square. So now you are getting, applying the standard formula, we are getting here 1, because when x approaches to 0, x square also approaches to 0, right? And we know limit x approaches to 0, tan x by x equal to 1, where x is measured in radians. So we are getting 1 into square of 1. I mean, we are getting 1 as the answer. Okay, so isn't it interesting? Yeah, so it's not very difficult what I mean to convey. Okay, next, third question is, okay, maybe quickly we can just check it. If I write here, limit x approaches to 0, log 1 plus x divided by e to the power 2x minus 1. Okay, so this is limit x approaches to 0, let us reduce this to standard form. Log 1 plus x, we need x here, right? Into x e to the power 2x minus 1. Okay, so limit x approaches to 0, log 1 plus x by x, that is 1, into limit x approaches to 0, here it is x e to the power 2x minus 1. Okay, and we have limit x approaches to 0, e to the power x minus 1 by x equal to 1. So its reciprocal will also be 1. It means this implies limit x approaches to 0, x upon e to the power x minus 1 will also become 1. Okay, so the power of e we cannot change, but we can manipulate this thing, we can manipulate, right? So we can have limit x approaches to 0, 2x by e to the power 2x minus 1. So 2 we have multiplied here, so maybe I can take like this. Okay, so when you write x approaches to 0, 2x approaches to 0, so 2x by 2x minus 1, which becomes, this is your 1. So 1 into 1 by 2, 1 by 2 is the answer. Okay, so quickly maybe 3 more questions. Okay, so question number 4, I can take, okay, so maybe some questions from logarithmic, we already have done. Exponential thing, limit x approaches to 0, limit x approaches to 0, e to the power 5x minus 1 by e to the power 3x. If the question is like this, limit x approaches to 0, sorry, this should be only 3x. Yeah. So limit x approaches to 0, e to the power 5x minus 1. So we need 5x here. So it is 5x by 3x. Okay. So here if you have this formula, limit x approaches to 0, e to the power x minus 1 by x equal to 1. So e to the power 5x minus 1 by 5x. And when x approaches to 0, 5x also approaches to 0. So 1 into this x gets cancelled, common factor, into 5 by 3. We are getting 5 by 3 as the answer. Okay, so these are the some of the simple questions. Okay, so let's move towards a bit good questions. Okay, so if I write here question number 5, limit x approaches to 0. Okay, so let me take it as 1 minus cos 2x divided by x into e to the power 2x minus 1. Okay, so if the question is like this, so we know you are getting 0 by 0 here, right? So we cannot apply the value directly, and we know 1 minus cos 2x is 2 sine square x. Okay, this is x, and here we have e to the power 2x minus 1. Okay, so we have exponential and trigonometric, both the functions. So if I write here limit x approaches to 0, to I can write here sine square x, and denominator can be written as x square, here e to the power 2x minus 1 by x. Is it okay? Because you have x here, I have taken x square by x, right? So mathematically it is correct. So limit x approaches to 0, to this can be written as sine x by x whole square of this. Okay, now here 1 by, this is e to the power 2x minus 1 by x. Now when power of e is 2x, we need 2x in its denominator. Let me write here 2 and multiply 2. So limit of the product equal to product of limits. Limit of the quotient equal to quotient of limits also. So limit of this quantity you are getting 2 into 1. Okay. Limit x approaches to 0, sin x by x is 1. Here we are getting limit x approaches to 0 means limit 2x approaches to 0 also. E to the power 2x minus 1 by 2x. This becomes 1. So 1 by 2. So 2 into 1 by 2. Okay, you are getting here 1 as the answer. Okay, so quickly, question number 6. Okay, so if you have such questions like, yeah, I can take this question. One more simple question in, okay, so this is the question. Suppose you have 5 to the power x minus 1 divided by x. Limit x approaches to 0. If I write here 2x for example. Okay. So here you can write limit x approaches to 0. 5 to the power 2x minus 1. So we have limit x approaches to 0. A to the power x minus 1 by x log a. So we can have 2x here into 2. Right? So it means this 2 into log 5. That is the answer. Okay, our seventh question is, yeah. So if I write limit x approaches to 0, 8 to the power x minus 4 to the power x minus 2 to the power x plus 1 divided by x into tan x. Okay, so if we have this question, limit x approaches to 0, we have 4 and 2 and 8 equal to 4 into 2 power x minus 4 to the power x minus 2 to the power x plus 1. Okay, x into tan x. So here it is limit x approaches to 0, I can write 4 to the power x into 2 to the power x minus 4 to the power x minus 2 to the power x plus 1 divided by x into tan x. Now, you see the numerator can be factorized easily. If I write 4 to the power x common, 2 to the power x minus 1 minus 1 into 2 to the power x minus 1 divided by x into tan x. Okay, so that is equal to limit x approaches to 0, 2 to the power x minus 1 into 4 to the power x minus 1. Okay, and yes, we have x. So if I write here x square, and here I can write x by tan x. See, is it mathematically okay? Okay, great. So x approaches to 0, 2 to the power x minus 1 by x into 4 to the power x minus 1 by x, x by tan x. So here if you observe, yeah, we know limit x approaches to 0, tan x by x equal to 1 when x is measured in radians. But if we take a reciprocal of tan x by x, I mean limit x approaches to 0, x by tan x, that will also be 1. So this is 1 as x approaches to 0. This one is a to the power x minus 1 by x. Here we are getting log 2. Okay, and this is, okay, that is the answer. So one last question. Okay, so this is the last question of today's class, and yeah, if I write here question number 8, limit x approaches to 0, e to the power x minus e to the power sin x divided by sin x minus x. So if you put x equal to 0, you will be getting 0 by 0 form, right? So what we can do here, yeah, if you divide numerator and denominator by x, then also your problem will not be solved. So what I can do here, limit x approaches to 0, if I write minus of e to the power sin x minus e to the power x divided by sin x minus x. Okay, so we have the standard form e to the power x minus 1 by x. Right here we have sin x minus x. Now if I write here limit x approaches to 0 minus, I can write e to the power, okay, so if I write here, we need 1 here, right? Second term should be 1. So it means e to the power x. Okay, by taking like this, here it is e to the power sin x minus x minus 1. Okay, divided by sin x minus x. Okay, so what we can see here, see, whenever we take e to the power x common, so it means e to the power sin x by e to the power x, which gives us this term. Now when x approaches to 0, sin x minus x also approaches to 0. So as x approaches to 0, this limit is 1, and when x approaches to 0, e to the power x is also 1. Means you are getting minus of, as x approaches to 0, this is e to the power 0, I mean 1, and x approaches to 0 means sin x minus x also approaches to 0. And here you see this power and denominator same, so and sin x minus x also approaches to 0 as x approaches to 0. Means we are getting here 1. So your answer is minus 1. Okay, so these are some of the questions which I thought we should solve. Okay, and I'm sure exponential and logarithmic functions, I mean to evaluate the functions involving exponential and logarithmic, it's not a difficult task now. Okay, so thank you so much, and again my suggestion is to solve lots of questions, and you must practice enough, so that so enough practice, sufficient practice should be done, so that it will bring confidence in you to solve many more questions. Okay, so thank you so much. We have to wind up our class today.